Hi, this is Dave Redder. This is the third video in a series of videos about design patterns, roughly as were described by the Gang of Four, as we call them, in their book titled Design Patterns, Elements of Reusable Object-Oriented Software. The introductory video, video number 1, talks about that and generally what design patterns are about. And so I'd recommend, if you haven't seen that already, that you go take a look at it. The second video is a really simple one about the singleton pattern, and this time we're going to look at something a little bit more complex that has actually 4 classes that are part of the iterator. So the way I'm going to do this is I'm going to have 2 parts of part 1. Part 1 is just talking about iterators in a very specific sense and in the most common sense that we use them. And then the first part of that's going to be iteration without the iterator pattern, and we're going to convert that to an application that iterates using the iterator pattern, but in a very simple way. So with all that in mind, let me show you what the iterator pattern is about. And this is from the DO Factory, stands for Data and Object Factory. And I like their pages simply because they're very clean and simple. And they're pretty faithful to the definitions given by the Gang of Four. And part of the purpose of this course that I taught at the university level was to give people the essence of the Gang of Four's patterns, along with some kind of a little bit of a purist attitude about whether or not you've got it implemented or not. In practice, that may or may not be what you want to do, but at least it's nice to have the ability to do that if you want. So what the iterator pattern is a pattern that allows us to do this right here. And we're going to come back to this about 4 times through our discussion, but there's so much in here that's essential for us to understand to actually gain an appreciation for the iterator pattern. So that's why we need to come back to it. First thing is, it says provide a way to access the elements of an aggregate object. An aggregate object is an object that contains other objects. Most often the objects in the aggregate will be at least similar, but most likely they're going to be the same kind of thing. Sometimes you have to raise the level of abstraction some to say that they're the same kind of thing. For example, we could have things in the array with names, weights, and eye color, and then we might have 2 different kinds of things in there, animals and humans. And that might be some kind of stretching it a little bit to say they're the same, but you know, if we think about it, they're all animals anyway. And so we have to think that way when we think about aggregates. Aggregate objects are objects that are that kind of object, an object that contains other objects or things. And those are very common in software development. But oftentimes we want to make sure that we can go through all of these objects and cause each one of them to be modified in some way. For example, if we had a boatload of products and we wanted to increase our selling price on everything by 3%, then we would need to make sure that we got to every object in there. And so what we want to do, whether the aggregate stores these things in a sequence, in a linear sequence, 1, 2, 3, 4, 5, or not, we want to get through them that way. And that's this part, sequentially. And what we want to do is, actually I should have just done that. That's this part. And then there's a constraint on the way we can do that. And that constraint is this piece right here that simply says we have to do this to this underlying aggregate without any exposure of what it's stored like. So we might have something stored as an array, we might have it stored as a list, we might have it stored as a heap, stored in a tree or a stack, or who knows what kind of structure. But whatever we do, we have to ensure that we don't have to have any knowledge of that to use the iteration, the iterator pattern, to get through and make sure we get through all of the objects in the collection. That's what this is about. So let me go show you a piece of code. This is in Visual Studio 2017 Community Edition, which I use for all of these videos, and it's quite adequate to do just about, well, to do anything for this app or for this series of lectures. So let me just run this thing, and this is what it does. I've got this form. The form has a button on it, and it's got a list box. And when I click on iterate, it's going to iterate through a list of names, click on iterate, and those are the names of characters in Alice in Wonderland, and there's a good reason for that, by the way, and let me just show you that right now. What does the iterator do? We start at the beginning, we go on till we get to the end, and then we stop. But what do we start at the beginning of? Well, we start at the beginning of this sequence of things that we're going to go through. Now, they may or may not, again, be in an actual sequence the way they're stored, but that's the way we're going to do it. So we have to create a sequence in order to go through sequentially, and that's what we start at the beginning of, is that sequence. So if we look at this, there's some names in Alice in Wonderland, and here's why I chose that. It was written in November of 1865, Alice in Wonderland. Look what it said. The king said, when Alice said something about, I don't know where to start, and the king said this, begin at the beginning and go on until you come to the end and then stop. Everybody watching this video, I assume, knows what an iteration is about in terms of for loops and the like. Let me show you some code that goes with this. This iterate button right here is attached to a button click event handler. I'll double click that, and here it is. Here up at the top of the form class, I've created this form global object named names. It's an array of strings, and it's got those names in it. Down here, when I clicked on that button, it executed this event handler, and what did it do? It went from I equal 1 to 5, incrementing by 1 each time, and each time it adds that collection of, or that name to this collection that goes with the list box. But think about it. If we look back at this, begin at the beginning. How do we do that in this? We begin at the beginning by saying where the beginning is. That's what for loops are about. I need to tell it to start at the beginning right there. And I'm saying that the beginning is at item 0. We could actually put item 7 or 7 there if the array was big enough, and we could start at 7 and claim that that's our beginning. But in this case, we're going to start it at I equals 0. It then says, go on till you come to the end. Well, there's quite a bit going on here. This is the go on part. Once we've gotten done with one, then we go on by looking at the next one, which is I++. And then this is the thing that we use to decide whether or not we're at the end. So it's start at the beginning, go on till you get to the end, and then what do? We stop. And if you don't stop there, then you kind of look kind of silly. So here's the deal. Where is the stop part? It's in the definition of the for loop. For says start here, do this at every when you're done with each item. In other words, when we're done with this block of code, at the end of that, actually at the beginning of it, check to see if you're at the end or not. In other words, are you done? And if you're done, for defines it to say fall out the bottom of the loop. In other words, stop. So that's the essence of the for loop. There's really not a lot more to say about it, except in the context of the iterator pattern, and that's what I'm going to do next.